elements separately, and then this is not even glass, this is plastic. And all these metals, they do not occupy any space. One single truck, you can make nearly 20 houses like this. And the moment this is at a particular distance like this, the problem of some of the lizards, centipedes, also will not arise. And this is an air-conditioned room. And inside there is a bathroom, a restroom. And this can easily accommodate about 8 persons. You will be surprised, in all these cases, even several places like Japan, even though people are very rich, they do not stay in luxurious, huge buildings. The small room, there will be just like in a train, there will be beds. Exactly the same way, here there will be 1, 2, 3, 4, 5, 6. Other side, another 6 beds. So whenever organizations like this, programs like this are conducted, just for the sake of 1 day or 2 days, you getting an accommodation in a big hotel is very difficult. So using the available resources and minimum time, if you can make such type of arrangement for your friends who come to participate in these programs, it will inspire them to do better things in their life. So whenever you see such type of things, be innovative, be good, and try always to do some sort of help to a person who comes to participate in these programs. So that is about this. Next. Vivekananda said, freedom is the first condition of success. It's not a place to mention, but we do not belong to a particular caste or religion, or even country also. As engineers, we are all global engineers. Today's engineers are known as global engineers. So our ideas, our thoughts, our approach, everything should reflect our greatness. We should always, our common religion should be humanism, humanity. So with that view, if you always live, definitely one day or other you will become a great personality in your life and everybody will admire you. And this is what I want to say, to skill India as the best, skill yourself first. Next please. You are aware the previous slide is actually near the India-Pakistan border. Back please. In fact, you are seeing on the other side the photograph. This is the photograph of Muhammad Ali Jinnah, the father of nation of Pakistan. And these are all the flags of Pakistan. So just a few meters away you have Pakistan. Next please. Now, the only solution to the problems of the world is education or awareness. So what I suggest is, I'm sure most of the students, you are all very listening this program, participating actively, that is by bringing calculator, by bringing a dictionary, and also the small assignments which I am giving you are solving. I am assuming that you are good students. You are doing it. You are doing by default, I know that. And their education does not stop. Education starts when you start giving your knowledge to others. That is the point where education starts. So whatever you have learned, you try to teach the students who have not attended the class or your juniors. More than all these things, most of the points related to our subject and several other subjects, they are generic in nature. They are very general. Even they can inspire even an 8th class, 7th class boy also. So what my suggestion to you all is that you educate and enlighten students in villages of 7th class to 10th class. This is the most critical time. If you convince that particular boy or girl about beautiful things, they will not even listen to their parents. They will listen to you only. They will treat you with a lot of love, respect and reverence. And you teach them, you make a small PowerPoint presentation, go to a school in village, and then there may be only 5 or 6 students. Don't expect that there will be a huge crowd to listen to you. Don't expect it. So let there be only half a dozen guys. But teach them with utmost sincerity about the important aspects of environment, water, hygiene, that is health and sanitation, cleanness, then the systematic handwriting, and then habits and hobbies, and creativity. In all these things, you try to educate them and enlighten them, especially 7th class village boys and girls. If you can educate them and enlighten them and enthrall them or inspire them, then there cannot be a better contribution by you to the society. So from this tender age itself, start contributing something to the society. You are what you contribute. Why I am telling all this is, whatever you take, don't expect that everybody will change. I am telling 100 times, do you think that every student will come with a calculator? He will not come. People generally have a tendency not to change. They want a life, but they do not want to put their best efforts. They do not want to change. They want everything very easily. But out of the 100 student class, at least 1 or 2 students will be there who will change. Definitely they will change. That too, when they belong to 7th class or 8th class, and if you tell in a nice way, with a lot of love and concern, definitely majority of them may change. So in this process, you are contributing a lot. More than anything else, Vand ke kha. We have heard from Guru Nanak that Vand ke kha, whatever you have, you share with others. And Spardhaya Vardhate Vidya. Spardha means competition. Vardhate Vidya. That means whatever knowledge that you know, if you share it, if you give it to others, if you explain it to others, in the villages, if you spread it, then only your knowledge multiplies. So your knowledge gets glorified only when you give it away to somebody else. Don't keep it with you. We learn thrice when we teach others. So don't hesitate visiting remote places and trying to educate people about the good things that you have. Do you know the main advantage? What happens when you start teaching little children? They may not change, but you will change. When you explain him about good handwriting, he may not change. There will be a lot of improvement in your own handwriting. They may not have the habit of trimmed nails. If you tell them 2 or 3 times, in the entire class only 2 or 3 may change. Maybe entire class also may change. That is a different thing. They may or may not change, but you will definitely maintain trimmed nails. That is the advantage. When we speak, it helps us prosper a lot. Next please. And always try to enjoy nature. Once again, coming to the basic roots of life. What happens is, when you start enjoying nature, nature is in and around us. Everywhere there is nature. The moment you start enjoying everything in and around you, throughout life it becomes a habit. Like whatever is there in and around you, you will start enjoying it. If your close friend is there, you will enjoy it. If a stranger comes also, you will enjoy it. Because he also is your surroundings. Your basic nature changes because of this. That is the advantage of enjoying nature. This is a picture taken by me in a speedily going bus somewhere near, this is near Bhimavaram. Okay. All these pictures are hot. Hot in the sense only yesterday, day before yesterday only I have another similar picture. Another 2 for fun. For fun, don't think it is fun. Learning must be fun. Then only it gets into us easily. In a very casual way we should read. We should learn things, not with force. These 2, if you are lucky, can be a gate question or a question in the IAS examination. Any competitive examination, it can be a question. But it is not engineering. It is not science, it is just common sense. 8th class, 9th class, these things are taught. The first question is, water hyacinth is exotic species. Here, exotic means A, foreign, that is not native. B, exciting and fascinating, very interesting. C, a toxic, which is dangerous or hazardous. D, extinct or endangered. Extinct means that species is not there now. Now, it was there earlier. It has now faced extinction. Generally, some species are called endangered. That means they are in the danger of becoming extinction. When they are in a very big danger, and if we don't protect them, they become extinct. So what is your answer? Exciting and fascinating. Because from the word, it is very clearly understood. It shows that not even a single person amongst you is a Sudigadu also. If you have Sudi, if you have luck also, you can tell that. The correct answer is A. Foreign species. They are not native to a particular land. They are brought from a different place. For example, kangaroo is native, endemic. Endo means within. Kangaroo is endemic to Australia. If India starts going for kangaroo in a huge number, it is called exotic species. Hares are there, rabbits. They are originally from Australia. They are brought to India. After thousands of years, gradually, thousands of years, for a period of time, they have become basically exotic species, like that. For example, Mauritius is a country where mynas are native to India. Indian mynas, thousands of mynas were sent to Mauritius, so that mynas can grow in Mauritius also. They are native to Mauritius. They are now native to Mauritius, but they are basically exotic species. Like that, species native to one particular place, if they are introduced in another place, they are known as exotic species. What is water hyacinth? If you do not know, I am very, very sorry. Water hyacinth is, in Telugu, it is Kurrapudakka. Today, most of the water sources like canals, ponds, lakes, they all have become unfit to use. Mainly because of one species, plant species, that is water hyacinth, which is Kurrapudakka. So these are all very important, related to engineering, related to society, related to economics. Government is wasting a lot of money to clear the water bodies from water hyacinth. And it is connected to water supply engineering also. Today one of the topic is this, removal of color, odor and taste. The moment water hyacinth is there in water, it imparts a lot of odor problems to water. Second point, which of the following is not a synonym to the term faculty? I repeatedly tell people that we use words, but we do not know the meanings of that. We never bother to use a dictionary. We never bother to find the meanings of the terms using a dictionary in a professional way. Whatever your friend says or whatever you think is correct for you. We never calibrate our mind. Calibration means increasing the efficiency of mind. We never try to improve the efficiency of our mind or our ability to think. Whatever we know, it's all. Faculty means teacher. That's all. No other meaning. We are not interested because we know from the beginning we are saying he is a faculty member in Jntuk. Faculty means teacher. You have to assume that this is gate examination. First you have to guess the answer and then go through the dictionary. Directly if you see the dictionary and then tell the answer, whom you are fooling? What is your answer? Without seeing dictionary. Just guess using common sense. Huh? Which one? A, B, A is skill. Faculty means skill. Faculty means skill. Scholarly person in a college. Discipline. Is it discipline? Labor. Most of the competitive examinations, if you do not know the answer, don't think that you will lose 1 mark. If you are correct, you will get 1 mark. If you are wrong, you will get -1 mark. You cannot take a chance just like that. unless you have the habit of using a dictionary for simple words, you cannot do anything in life future. What all you will get is, in that Saudha competition, you all have come and the whole night I have danced. Only that happiness will remain with you. Nothing else. That you cannot write in your resume. The correct answer is labor. These are all the synonyms of the term faculty. You must have seen now in the dictionary. Those who did not bring the dictionary, God only helps. What are the meanings of the term faculty? Discipline means subject. It is civil engineering faculty. It is mechanical engineering faculty. Which discipline you are in? If somebody asks you, you should say I am in civil engineering. Subject. Discipline means a subject. So how many faculties are there in your college? There are 6 faculties. Something like that. The department offers 2 faculties or 6 faculties. College faculty, like that. So discipline, skill. Faculty means skill. Scholarly person in a college. Teachers of a college or university, they are known as generally faculty. We generally do not call teacher of a primary school as a faculty. We cannot call a teacher in a primary school as a faculty. In a college or university, a teacher in a college or university is called faculty. But it's okay, it is close to that. This is okay. Next. So this is also a picture by me yesterday. This is what is water hydrant. It is a very thick color leaf, and it completely dominates the water body. The main reason for this is a thick, lush green field where we use a lot of fertilizer. Fertilizer contains nitrogen, phosphorus, potassium, NPK value. That is how a fertilizer is designated. When we use a lot of fertilizer, the excess fertilizer gets into the groundwater. So the groundwater is contaminated by nitrogen. We always have seen that it causes blue baby disease. We have studied. How many of you remember? What is the technical name of the disease? Very good. Methamoglobinemia. These things you should by heart. If 1 or 2 students tell the answer, there is not sufficient. This is what his knowledge is. Don't think that just before examination, if you see, you will remember and you will write down. Definitely next minute you will forget. Methamoglobinemia. So this disease is a very prevalent disease, especially children of age less than 1 year die because of this. So this is, if nitrogen concentration is very high, or even P and K, they are called nutrients. When their concentration is very high, then what happens is the biodiversity of this water pond decreases. Diversity means variety of life. Bio means life. So instead of having a large variety of life, like different types of fish, different types of microplankton, different types of zooplankton, large variety of species are there. Diversity is always strength. Any system can survive only if diversity is there. So the moment NPK value increases, all these higher forms of life, they die. And only some species which are nutrient specific, that means high concentrations of nutrients in their presence only, these they survive. For example, water hygiene. It consumes huge amounts of NP and K, and they start growing. They are like, they do not allow other species to survive also. They do not allow. They completely dominate the system, ecosystem. So as a result, the moment they start growing, you will not have any life in this. Life means there will be only water hygiene. Fish die. All other animals, they die. So how to clear this water pond is a very big menace, very big problem today. So treatment of water for the removal of these organisms also is there as a part of syllabus. in your case. You should know it, and government is spending a lot. You must be seeing in several canals, they tie some ropes to that, and with the help of some people, they will be pulling them and pushing them onto the ground. Again they comes, next year again it comes. And because in 3 weeks time, in exactly 3 weeks time, this water horizon becomes double. So after 6 weeks, 4 times. After 8 weeks, 16 times. 8 times. Like that. It multiplies very quickly. Every 2 weeks or 3 weeks it multiplies. Double, double, double. So it's very difficult to control it. Next. Let's get back to this beautiful problem today. Our topic is advanced removal of treatment. But before going to that, we'll solve an important gate problem. Today we are all aware that lengthy problems also are given in gate examination. Why they give lengthy problems? First point is, they do not want you to remember any data. So all the required data, maybe or may not be useful type of information also they provide in the question. That makes the question lengthy. But what a common student thinks is that the moment he measures the toughness of a problem based on the length of the problem. If he finds it very large, immediately a common man crumbles. He thinks that it is very tough. It is only some information he has given because he wants to make it clear. There should not be any ambiguity in the question. You know ambiguity? Ambiguity means confusion or having no clarity. So the same sentence he tells, explains in another style also to avoid any confusion. That is the reason the question is lengthy. So this is a very important question. They give question like this. Second reason is, in the same question, there will be 2 or 3 different types of questions will be there. Each question will carry 1 mark or 2 marks. Design a clarifier to treat 8 ml of water such that the first question is very simple. You can do it. You can design a clarifier for any flow. 10 ml I have done it earlier. Twice I have done this problem. Now this addition is, so gate questions are just like the classroom study only. Only thing is you have to bit extra you have to study. Maybe another 15-20 minutes if you spend time every day. Gate is a peanut. Very small thing. 1. At least 70% of all particles with ring velocity of 2.5 meter per hour or more are removed. And 2. A minimum detention time of 3 hours is provided. These 2 are the conditions. Find the percent removal of the settling tank of particles having settling velocity of 2.5 meter per hour, 1 meter per hour, and 0.2 meter per hour. So, to solve any problem, engineering is from ingenium. Ingenium means skill. Which skill? Problem solving skill. How to solve a problem? What is the first step? Put pen on paper. What is the second step? Given data, you write it. You put it on the paper. In standard units. With units and with standard units. He may give the diameter in meter of a particle. Or he may give the diameter of the particle in mm. Maybe you have to convert it to meter. He will give it in foot per inch square. You have to convert it to kg per centimeter square. So convert all those parameters. And next step is write the appropriate formula. What is the only formula you have studied with reference to efficiency of a settling tank? What is meant by efficiency? Next please. This is the efficiency. Maybe you can increase the size. Size can be increased. Total. Efficiency of removal is equal to Vp by Vd. P is particle, D is a design velocity or critical velocity. See. Design velocity does not change, but velocity of the particle changes because the particle settling in a clarifier will be of different sizes. And velocity of the particle is by g by 18 into s minus 1 into d square by nu. So d is the diameter of the particle. So there will be clay in that, there will be fine silt in that, there will be coarse silt in that, there will be sand in that, there will be particles of different sizes, diameters. So each particle will have its own settling velocity. Some particles settle faster, some particles settle slowly. So different particles. So what is their efficiency? That is what we are studying. Surface. So what is the efficiency of removal? Vp by Vd. We designed for a particular velocity. That is called design velocity. We all have studied that if the velocity of the particle, for example, if it is sand or gravel, diameter is very large. So settling time will be, it is d square by nu. So settling velocity will be very, very fast. So it will settle very quickly. So it will be more than the design velocity. So what is its efficiency of removal? 100%. So if velocity of the particle is more than the design velocity, it is 100%. Removal is 100%. If velocity of the particle is just equal to Vd, it is 100%. 1. But if the velocity of the particle is less than Vd, for example clay, then only a small percentage of it will be removed, depending on the size of the particle, like that. So, efficiency is 0.7. That is what question says, that minimum 70% of the particles should be removed. Whose settling velocity is 2.5. So, 2.5 is settling divided by Vd. Therefore, what is the design settling velocity? 2.5 by 0.7, which comes to 3.5 meter per hour. So this is the surface loading or settling velocity, which is equal to 3.5 meter per hour, which is 8.7 meter cube per day per meter. You multiply the 4, you will get per day. Another percentage. Okay. So what is the surface area of this tank? Flow is known as 8 ml, 8000 meter cube per day, divided by 85.7 meter cube per day per meter square, or 85.7 meter per day. Both are same. So you will get per day get cancelled. Meter cube by meter is equal to meter square. You will get the meter area. Finish. Now, if detention time is 3 hours, capacity is equal to how much? Observe the units. Don't by heart anything. Be calm and cool. Just observe. And when you are observing, when you are studying, don't think about the past, don't think about your future. Be in the present. Be calm and cool. 8,000 meter cube per day into and then 3 hours. 3 hours means 3 by 24 day. So 3 by 24 into day. Day get cancelled. You will get 1000 meters. What is the depth? 1000 divided by you will get 10.5 meter, which comes to 10.5. As maximum depth to be provided is 5 meter, increase the area to 200 meters square. This data is given, maximum depth given is, generally we do not put for more than 5 meters. You have seen clarifier. So surface loading is 40 meter cube per day per meter square. So provide 16 meter dia by 5 meter depth clarifier. Critical velocity in the basin is equal to how much? Surface loading is equal to 40 meter cube per day. No, after 1000 meter cube, no, you can just ignore that. Come back to the last 3 lines. Last 3 lines. Percent removal of particles having Vs is equal to 2.5 meter per hour. How much it is? Is it clear now? Forget the last 3 lines in green color. If detention period is 3 hours, capacity is 1000 meter cube. Is it okay? Okay. Next step. Last 3 lines. Percent removal of particles having Vs is equal to 2.5 meter per hour. How much? Why? Because this is 3 point, design is 3.5 meter per hour. 10 calls. Design is 3.5 meter per hour. Settling velocity of the particle here is 2.5 meter per hour. So Vp is more than Vc. So it is 100%. Go to the second point. Second problem. Percent removal of particles having settling velocity of 1 meter per hour. 1 divided by 1.67. Is it okay? Okay, whatever it is. We have done a similar problem earlier. Do you remember it? What is the efficiency of removal of particles? Velocity of the particle divided by design velocity. So here, forget about all this. Maybe somewhere some flaw is there, some mistake is there. So come to the last, that particular point. 3.5 meter per hour is equal to 85.7 meter cube per day. That is 100% correct. So based on this, now go back to the question previously. So that 70% based on that you have this velocity are removed. So this question you have got the answer. The design velocity you have found it as 3.14 meter per hour. What is the velocity of the particle here? So how many will be settled? 2.5 divided by 0.14. You will get again 70% only. Second question. A minimum detention time of 3 hours is provided. For 3 hours you have calculated the velocity, volume, isn't it? 3 hours means 3 by 24 days. Multiplied by flow in meter cube per day. You will get so many meters. You have got that. Then find the percent removal in the settling tank of particles having settling velocities of 2.5 meter per hour, 1 meter per hour and 0.2 meter per hour. How do you get it? Answer 2.5 divided by 3.16. 1 divided 3.16. 0.2 meter per hour divided by 3.15 meter per hour. 3.5. Next please. These are exactly the same thing. Last 3 lines only bother. Last 3 lines. They give the option 2.5 meter. Why you have given 100%? Huh? Okay. So here is a calculation mistake maybe there, but you are clear now? ఎక్కడ వచ్చింది? Okay, whatever. Is it correct? You are clear now, right? Otherwise, we are here as guides or supervisors only. There is every possibility that there can be a mistake here. But forget about this. You know the basic that velocity of the particle. You know this. Once this is done, the remaining thing is only that divided by this. Next, please. Another important topic today is removal of algae and fungi. Both are plants. They are microorganisms. Microorganisms means which are not with naked eye. But what happens is algae often we can see not as an individual, but algae sometimes when they come together, they form something like a small colony which becomes visible. And after some time what happens, that small colony, several colonies they combine. And sometimes it becomes a family. And another 100,000s of families they combine, they form a very, very, very huge mass. And all such huge masses they combine sometimes. And they, even sometimes about 50 to 100 square kilometer area of the sea also is covered sometimes by algae. Kashmir Dal Lake is there. Sometimes when you go, you don't see even a drop of water. The whole thing will be covered by red-green algae. So they multiply in huge numbers whenever nutrients are available in plenty. So let us see the main points related to this. Algae are small chlorophyll-bearing unicellular plants of varying shapes and sizes and live in water when sunlight is available. They are known as, please write one word, phototrophs. They are known as phototrophs. Photo means, the dictionary meaning of the term photo is light. So whenever we already have studied in case of clarifier, what happened in case of disinfection, pre-chlorination we have studied. Wherever sunlight is available, they come because they want sunlight. Many plants also, what happens is, suppose you have kept a plant, a creeper inside in your house, then it wants sunlight. What they do is generally somehow they crawl and go, and even if a small opening is in the house, through that they go and in search of sunlight. So algae also is like that. It is, you cannot say it is fond of sunlight, it cannot live without sunlight. Earlier you have seen water hyacinth. Water hyacinth and algae also, removal of algae also is a very big problem. In Telugu it is called Moocs. So they are phototrophs. They want light. They cause an apparent color and turbidity to water and also taste and odor problems. What is meant by apparent color? We have studied that color is caused by dissolved solids. But algae does not contribute to dissolved solids. It is not in a dissolved state. But if algae is present, color is caused. So it is not a true color. It is color only, it is not true color. Because technically we are saying that color is that which is caused by dissolved solids. That is how we have defined, as engineers, as persons, we have defined certain thing as something caused by dissolved solid. But this is not dissolved solid, but it is causing color. That is why it is called apparent color. For example, it is called, in English there is a term called pseudo-hotness. What is meant by pseudo-hotness? Please write that. P-S-E-U-D-O, pseudo. Pseudo means pseudo-doctor. What is meant by pseudo-doctor? Fake doctor. Fake. Is not the proper. Pseudo-psychologist means fake psychologist. We are all fake psychologists. Pseudo-hotness means it is not fake hotness, it is not true hotness. See one point. Sea water, such small things only can help you in a great way when you want to make a difference in competitive exams. If you listen, they will be imprinted. What is hardness technically? Hardness is the property of water because of which it offers resistance to formation of lather with soap. Now, seawater is there. Seawater has hardness in it. But due to other salts present, if you bathe with seawater because of those salts which do not cause hardness, soap, if you wash with the soap, lather is not formed, foam is not formed. If you think that it is due to hardness it is not formed, you are mistaken. It is not the hardness there. But what we think is that because it is not forming lather, so the water must be hard water. You are thinking like that. So, it is not forming lather because of another chemical reaction, not hardness. That is why it is called pseudo-hardness. Am I clear? So, seawater's, that is pseudo-hardness. So, similarly here, apparent, it is not true color, it is apparent color. Algae can be controlled by excluding sunlight. So how to kill algae? They cannot live without sunlight. So stop sunlight. In case of reservoirs, chlorine or copper sulfate are added from boats by means of sacks containing these crystals. Sacks means bags. Bags. In the movie, he tells some Narayana, somebody, that you want to become a hero, but here you have 2 sacks like carry bags. కళ్ళ కింద క్యారీ బ్యాగ్లు వచ్చినట్టుగా వచ్చేసాయి, అంత ఓల్డ్ అయిపోయి నువ్వు హీరో ఏంటని. సో దే ఆర్ నోన్ యాజ్ సాక్స్. సో ఇన్ ఎ బ్యాగ్, ఇన్ ఎ క్లాత్ బ్యాగ్, కాపర్ సల్ఫేట్ is kept and it is tied, and that is tied to a boat. What happens when the boat moves? Gradually copper sulfate gets dissolved in the canal or water pond or whatever it is. With that, what happens? Because of that, the algae are killed, microorganisms. So it is like that. So the most important aspect, this point is, without this you cannot write an exam. Take it for granted. Very important. Because removal of color, order and taste is a very, very important question. In drinking water also you can write. Somewhere or other, they will not ask you this question directly. You have that knowledge, you have to exhibit it somewhere or other. That is called smartness. When you have knowledge, you exhibit. You will not get any other opportunity. Environmental engineering, you have studied the entire subject. Some important points are there, very key points which are essential throughout your life. And he may not ask you, but if you don't exhibit, when will you exhibit that knowledge? If Karna had failed in Mahabharata, the main reason is this. He had so many astras, but he did not use it. If he had used all the astras which he had, maybe the story would have been different. When you have weapons, when you have knowledge, exhibit it. It's a very important point. The only thing is you should have the smartness of when at the earliest. For some question or the other. So how to remove? Next point. Algae can be controlled by excluding sunlight. In case of reservoirs, chlorine or copper sulfate are added from boards by means of sacks containing these crystals. If they are not removed, filters may be clogged frequently. You already studied in pre-chlorination. Fungi are non-chlorophyll bearing plants and hence can grow even in the absence of sunlight. Fungus is also something very dangerous. They all come as plants. Occasionally they grow in large numbers in water mains. Water mains means the main water supplies, causing disagreeable odors and tastes. Fungi also can be removed by CuSO4 and chlorine. So copper sulfate is something which is of a great use. For example, in your house, in every individual house, suppose a water tank is to be clean. Even today many people use copper sulfate. And when everything is clear, they use at the end bleaching powder. It is a very common practice. Similarly, huge ponds, swimming pools, or things like that are badly polluted, huge areas. Generally, bleaching powder is not used directly. It is only copper sulfate which is used first. As a last treatment, they use bleaching for chlorine. Next, please. I will ask another question. A multiple choice question. Let us see how many of you will answer. The question is like this. What is the best water among the following? Which one is best preferred for planting, for watering plants in your house? Question is clear? For watering plants in your house, which of the following is best preferred? Please write. A. Sea water. B. Municipal water. C. Distilled water. D. Groundwater. Which one is best preferred? Very good. It is groundwater. In fact, all other waters are unfit to be used for watering plants. Why? Municipal water is unfit to. For us it is okay. We are bit strong. We can withstand. Municipal water contains chlorine. Water plants, for watering plants, chlorine content is very dangerous. Don't do that. Second, once in a blue moon is okay, but on regular basis. Second, seawater. Seawater has so many salts in it that it cannot withstand. Chloride concentration, if it is more than 1000 mg per liter, plants or irrigation or agricultural lands, they cannot survive. Any agriculture, any plants, anything, chloride concentration should not be more than 1000 mg per liter. Whereas in seawater it is not 35,000. 35,000 is total salts. Is tedious. Chlorine is only about 15,000 or 14,000 mg per liter, 50%. Others are sulfate and other things. Total it is 35,000. So seawater also you should not use. Next is distilled water. Can you use distilled water? Plants need some nutrients, some minerals, etc. If you provide it pure H2O, is it chemistry subject? It is like teaching chemistry to a plant. What is that it is pure H2O? It is of no use. Can we use pure water for drinking, distilled water for drinking? Distilled water is 100% pure. But it is not the purity alone. Same is the case with any student also. You are a very, very good student. You do not harm anybody. You may not become great. To become great in life, goodness is not a criteria. If you are very dull, you are not harmful to anybody. You are just coming, going. What is the use? Okay. You should have some salts. Okay. So what is the answer? Groundwater. Let us go to another topic. That is removal of color, odor and taste. Whenever the letter L, R comes at the end, it should generally become silent. That is one skill, English skill. You should not say colorer. It is color. You should not say orderer. It is order. Order. You should not say teacher. It is just simply teacher. Teacher. Motheru, fatheru, brotheru, all these are wrong. You don't have a single brother in life. You have millions of brothers. Brother, mother, sister. Okay. Kada. Order. Order. O-D-O-U-R also is correct. O-D-O-R also is correct. But many students, what I observe is, when they go back after my class, the whole night up to 12 o'clock they will discuss whether O-D-O-U-R is correct or O-D-O-R is correct. Like dogs, they fight and they skip. And all these important points disappear like camphor. Okay. Removal, potable water supplies and manufacturing or processing of food and drinks demand water that is free from color, odor and taste. This is very, very essential. Phenols combine with chlorine to form chlorophenols with very strong medicinal taste. We are talking about sources of color, odor and taste. Dissolved gases and algae also cause taste and odor problems. Chlorine, KMNO4 and O are very strong oxidants capable of throwing. Carrot is like it. Then all leafy vegetables, most of the leafy vegetables, they are full of iron. So you must eat. And some types of things are there which are full black in color. You don't think that it is black actually, it is red. If you anytime observe blood, after some time it becomes something like thick black color almost you will find it. So this black color also, some fruits they appear dark black, almost like black they appear. But for example, strawberry, all these are full of iron only. It is only the iron which gives the red color to them. So eat them. Just by eating you will get the real beauty you will get it. Otherwise it is only pale. Pale means white. So opalescence means, what is it written in dictionary? Not given. White it is written. Okay. It is a white color only. So it is something like a whitish color. Okay. So this also is an important. These 3 points are very essential. Iron gives red color to water. Manganese gives black color to water. Zinc gives opalescence. Iron, manganese and organic substances, they impart lot of taste and odor to the water. Chlorine can remove all these. This is a small point, but somewhere or other in the examination you have to write, dump it. Okay, last point you see it, chemical coagulation is an effective method to reduce the color level of the raw water. Okay, next please. How to remove iron and manganese on a large scale? Large scale. Iron and manganese are like brothers and mostly live together. It is a generally we write like that so that we can understand things, we can visualize things. When I write like that, if he writes it as friends, it may be better or something like that. The moment you discuss and start saying like that, you will remember the point throughout. That is the idea. That is it. There is nothing like a bad example. Fe and Mn are soluble only in the absence of dissolved oxygen and at low pH values of below 6.5. Iron is mostly available in water as ferrous carbonate. This is all not that important. Right? Dissolved iron and manganese are found in groundwaters located in shale, sandstone or alluvial deposits. After oxidation or aeration, Fe turns into an insoluble ferric form that can be removed by settlement and filtration. Thus, this is very important. Thus, iron is usually removed by aeration of water and pH adjustment to above 6.5. For removal of manganese, pH should be higher than for removal of iron. Oxygen required for oxidation is supplemented by an oxidizing agent like KMnO4, and zeolite regenerated with KMnO4 or a normal sand filter also can remove manganese. Next please. Yeah, this is the heart and soul of the class. This is the technical point. Following are the reactions involved in the removal of iron and manganese. What actually happens when you add KMnO4 to water containing iron or manganese? There is no other go, you have to remember. If you don't remember the equations completely also, maybe it is okay. But the last sentence is the key for the complete subject of removal of iron and manganese. This is there in syllabus as a separate topic. It's very, very important. Future also it will be helpful. In GATE also this syllabus is. The basics of that depends on that equation, but the last line in blue color is the key. That FeOH, you are seeing that, ferric hydroxide. It is like a precipitate, it is very heavy, so it settles to the bottom, so it can be easily removed by clarification or sedimentation. But if you add 1 mg per liter of KMnO4, it can oxidize, that means it can remove or it can destroy 1.06 mg per liter of iron, Fe, and 0.52, sorry, it is not gram, it is mg. 0.5 it is not gram, it is mg only. 0.52 mg per liter of Mn. Next please. No, you will get it, don't worry. Next please. You solve this problem. I always believe that you solve problems, you will understand the subject very easily. The previous slide ended with the term theoretically. Why should end with the theory? Let us see, start with the problem, how easily you will understand. I will give you sufficient time, do it fast. A water supply system supplies water with 2.5 mg per liter of iron and 1.2 mg per liter of manganese. Find the quantity of KMnO4 required to remove Fe and Mn if a flow is 2 mld. 2 mld can be the flow required for an industry. 2000 meter cube per minute. The answer is simple. Every 1 mg per liter dosage of KMnO4 removes 1.06 mg per liter of Fe and 0.52 mg per liter of Mn. So, dosage of KMnO4 required is equal to how much? 2.5 into, is it clear now? 1.0 mg per liter of Fe. If it is to be removed, we need 1 mg per liter of KMnO4. If 2.5 mg per liter is to be removed, 2.5 into 1 by 1.06 plus every 1 mg per liter to remove 0.52 mg per liter of manganese, we need 1 mg per liter of KMnO4. So if what is the quantity, what is the dose of manganese? 1.2 mg per liter. To remove 1.2, how much is required? 1.2 into 1 by 0. So we will get 4.662 mg per liter. What is the discharge? Q is equal to 2 mld. 2 into 10 to the power of 6 liter per day. So what is the daily requirement of KMnO4? Liter per day multiplied by mg per liter. Liter get cancelled, you will get milligram per day. Don't worry, be cool. Be cool. World is very easy to become a scholar, especially in modern world. 90% of the students, they do not 20% of 500. 90% of the students today, they do not know the spelling of science. They do not know the spelling of the term environmental. There are some of the students who are listening today this class, they do not know what is going on. They are simply sitting, that's all. They do not do anything. They do not know how to use a calculator. It is fact. In such a type of very clumsy world, if you are good, if you have good habits like bringing calculator, and then if you have some interest as investment, they are all very small things. They do not need a very big mind or brain or something like that. Just you have to put some effort. Hard work also is a form of intelligence. Just like enthusiasm is a form of intelligence. If you have interest, if you want to learn, that itself is a component of intelligence. The intellect automatically develops the moment you have interest. Similarly, if you are putting hard work, you are trying, maybe you are not getting the correct answer, but you are trying, you are putting some efforts, you have some discipline, then that itself improves your intellect. Is it clear now? Simple? Done? So if the flow is known, what is the main point here you have to understand, which you must write in the examination when it is asked or not asked also? In one box, what you will write? 1 mg per L dosage of KMnO4 removes 1.06 mg per liter of Fe. Put full stop. 1 mg per liter dose of KMnO4 removes 0.52 mg per liter of Mn. That is a different sentence. What happens if you write and 0.52? You may think that if you add 1 mg per liter KMnO4, it will remove both, which is wrong. 1 mg per liter can remove only either, am I clear now? There is not a difference between it. So to avoid confusion, write it as separate sentences. Next please. What's time now? 3:30. Hurry up. So how iron and manganese are removed in a municipal water supply system, if it contains? So take the raw water, then take it to chlorinator. Add chlorine. If you add a chlorine, iron and manganese are removed. That is what we have studied. Then send it to aerator. What happens if you aerate? We have also studied that aeration removes iron. So that means you see that if the water is sprayed, in the process it is removed. Then you send it again to chlorinator. Then you send it to detention basin. Why detention basin? Fe. What happens when you add Fe, KMnO4, things like that? Ferric hydroxide precipitate is formed. Right? Then you send it into some detention basin, where see that it is retained for some time. Something like a setting tank. In a small tank it is retained. It comes down. Then you send it through a sand filter. Then you send it to ammonia content. Why ammonia content? You have seen that breakpoint chlorination occurs at dash 7.6:1. Please write that one second. Cl2 is to just good system. What is it I have to write? Yeah. Cl2 to NH3. If you write it as NH3 also, it is okay, but you are 90% correct. Be 100%. 7.6 is 1. What does it mean? If nitrogen concentration, ammonia nitrogen concentration is 1 mg per liter, you have to add 7.6 mg per liter of chlorine. At that point only breakpoint chlorination comes as in a marked way, in a very clear-cut way. So that is why in the previous thing when you say for what is breakpoint chlorination? It is the point at which water is 100% pure from. Go back to flashback. It is the point at which water is 100% pure. It is free from iron, manganese and organic substances and the color and taste and odor caused by them, and also the pathogens present in water. That is what we have studied. So the water is 100% pure. So to make it 100% pure and potable for drinking, please go back to your. So for the clear-cut demarcation of the break point, ammonia contact is provided. Otherwise it is this. Next please. Same is the case in case of chlorine. Ozone also can be used. We have studied chlorine and ozone, they have both the effects. Both are highly powerful oxidizing gases. So if ozone is used, this is the system in which it is used. Next please. Adsorption we have seen the basic definition. Next please. Okay. The last topic of the system and subject, 5th chapter, and that is but a very important topic, and that is removal of fluoride or fluoride, about fluoride. Many waters, they do not have sufficient amount of fluoride. Then fluoride can be supplemented also. If sufficient water is not there in drinking water, sufficient fluoride is not there, because fluoride is an essential component for the formation of strong, hot and durable heat. Fluoride is supplemented, that means it is added. But 90% of the cases throughout the world, fluoride is a problem because its concentration is high. So removal of fluoride is the main topic discussed here, not addition of fluoride. Of course, both are problems. Fluorine, the most electronegative of all elements, is highly reactive, is never encountered in its elemental gaseous state except in some industrial process. It occurs mainly as fluorspar, rhyolite, Nespress. Fluoride minerals are nearly insoluble in water. Fluorides are present in groundwater only when conditions favor their solution. Fluoride is also present in seawater and drinking water supply. Here you have to know one point, and that is, when Nagarjunasagar Dam was constructed, during those times, the problem of fluoride was not that grave, serious. It is not there. It is reasonable. What happens when you construct a dam, or Srisailam or Nagarjunasagar Dam you have constructed? Then what happens? It is of height 150 meter or so, dam height. So that means normally the water level was flowing at, let us say, zero level, normal level. Now you have constructed a 150 meter tall dam. Then a reservoir is formed, a huge reservoir of height 150 meters. What is the pressure acting on the normal ground level? 15 kg per centimeter square. Earlier water was flowing through ground at almost atmospheric pressure. But now at 150 kg per centimeter, 15 kg per centimeter, almost like reverse osmosis, it is flowing through the sand bed. So what happens is, this water will fall into the deep ground where these minerals were all present in a solid state. What happens if they come in contact with water? Gradually the fluorine in that gets dissolved in this water. And when there is a ground well, a tube well, if you dig it, what happens? This water gradually, through the pores of the underground water, it gradually sucks to the surface. How plants suck water from the deep ground? Because there are capillary tubes, small tubes. The pores with sand particles, they act as small capillary tubes, and the water rises. There is no plants drink water. Just like we drink cool drinks using straws, they drink water like it rises. Earlier that water was safe because it was not in contact with these minerals. But now, because you have constructed 150 meter tall dam, it exerted a hydrostatic pressure, because of which all these minerals were dissolved in that, and today we are suffering that the concentration of fluoride in that water is very, very low. So whenever you go for a huge project, it will have a definite environmental impact on the people in and around. Next is, what are the effects of fluoride? We have already seen it. This is just recollecting that. What are the standards for fluoride in drinking water? Even I don't remember exactly. I need not remember also. You should remember. You are going to give the examination. But I use only common sense. That I know that it is around 1 mg per liter. 1 mg per liter is the desirable standard. 1.5 mg per liter is the maximum permissible standard. If it is less than that, it is not good for the formation of good, strong heat. And if it is more than 1.5 mg per liter, it leads to fluorescence or discoloration of heat and then bone fluorescence. Mortality. Next is, defluoridation is the removal of excess fluoride from water. The National Environmental Engineering Research Institute, NERI. If somebody asks you what is NERI, every one of you must know it, because it is the premier institute in the entire country related to environmental engineering. Every one of you must know it. National Environmental Engineering Research Institute, which is located in Nagpur. It is a center, it is the prime body. By WWF. Hey. I want correct answer. How many of you are confident that you know the answer? What is it? Tell it loudly. World Wildlife Fund. Let everybody say. WWF stands for World. Let me tell you. Please. WWF Fund for Nature. Don't argue saying that for nature is there, so WWF young should be there. It is not there, so you are. Don't argue like that. You should know the answer. I told the same answer I told earlier. Because it is your habit to forget important things. You forgot. Now you are ready to pick up power. What is meant by MOEF? What is MOEF? Explain. Very good. If you say Ministry of Environment and Forest, you are wrong. It is Ministry of Environment, Forest and Climate Change. Okay. India has evolved an economical and simple method of defluoridation, removal of fluoride, which is referred to as the Nalgonda technique. The very name of the technique itself is Nalgonda technique, because Nalgonda is world famous. Highest levels of Nalgonda. Of course, there are places like South Africa. There are so many countries, and in India, so many states which are suffering from this high levels of fluoride. But Nalgonda has its own uniqueness that is suffering a lot. 25 mg per liter of fluoride also is very common in areas of Nalgonda, whereas 1.5 mg per liter is not good. And if it is more, please note that if it is more than 5 mg per liter, it is lethal. Lethal means very dangerous. Very dangerous. Your bones will become brittle. They will bend also. You cannot walk. People, when they walk with force also, they are broken. It becomes like. And the teeth will be red or black in color. It gives a devilish nature to a person. Black teeth, you imagine. Red teeth. Next please. Typical treatment of fluoride is the Nalgonda technique, and that is fluoride water. System very similar to this is devised by UNICEF. What is UNICEF? You all know that. Don't tell. You know that. You all know it? So why you are having such a serious face? Generally, when a person tells a lie, and when I look into that, there will be a smile on the face. Generally. Let me see how many of you are smiling. If you are not smiling, it means you do not know anything. You have not even understood the question. Oh God. You know, especially on similar basis of removal of fluoride at domestic levels. Domestic means household levels, like this. We have come to the end. So typically fluoride removal is like this. There the fluoride is 6 to 8 mg per liter, and here it is fluoride is 6 to 8 mg per liter. Then the water is pumped here. Here Al2O3 it is pumped. Then the fluoride level is reduced to 1.5. That's all. So what is the main element added here? Al2O3 is added. It is alum is added. Alum only. It is a commonly used chemical. Alum and lime and bleaching powder combination is used in the Nalgonda technique. What are the chemicals used? Use alum and lime. Of course, chlorine is always added as for chlorination. So that's all. So alum is added, and this is backwashing, spent reverberation, and then this is evaporation. Simple diagram. Next question. Last and final slide. Thank you very much. So with this, the topic of water treatment is over, and next time when we meet, we will start the new chapter, the last chapter of this session, and that is distribution of water. It is almost it is how distribution of water, and once again what different types of pipes are used, and how to solve the pipe networks, how water main appurtenances are there, how water line is laid, and how water supply system is maintained by the municipality. Tomorrow when you become the municipal engineer or executive engineer of a municipal corporation, one of the important roles you will be playing is supply of water. Most of our students throughout in USA, most of the municipal engineers in several cities, the municipal engineers are all from, majority are from Jntuk. You will be surprised to know that most of them, they are the in charges of water supply in many towns in the US. So this topic tells you about how now you have treated water. It is ready for the supply. But the most critical thing now is how to make it available to the person in the remote farthest point to his satisfaction. And what diameter you have used, what type of valves you have used. And in case of any emergency of your pipe is broken, how to see that